So today we have a graduate student from Stevens Institute of Technology in the School of Systems and Enterprises. His name is Pouria Babvey, and he's going to be talking about some social media content today. So please, Pouria, go ahead.
Thank you so much. Okay, so thank you everyone for attending in this presentation. And this presentation is a bit different from the previous presentations that we had. They were basically based on the more hands-on optimizations with applications with applications in different fields, from electrical engineering, transportation, and other stuffs. Today we are talking about the application of social network analysis to understand better our society and how they provide feedback to the events that are going on in our society. And the tools that I'm introducing today is, I'm sorry, I'm looking for a good place to see myself and the audiences, but let's go ahead with this format. So we are introducing a tool that can have applications in large areas in systems engineering. And during the presentation, I explain how it works, how can we apply the methods that we developed in different areas. And I really appreciate if you provide feedback and share your comments for possible collaboration in the future. So the term that we use is content-aware galaxies, and we regard a network between tweets instead of a line of research who consider the network between users, and then use those network between tweets as a digital fingerprints of discussion over social media. So as an example, politicians and public figures mobilize users for a large-scale discussion over controversial topics. And as you can see, for example, tweets by President Trump's generated a discussion involving, for example, in the first example, 70,000 with 70,000 replies. It was about the consumption of hydroxychloroquine as a possible medication for COVID-19, and the next one with 120,000 replies about the global warming. So we think that discussion threads, the reply chains, provide a useful tool to understand what's going on in our society under the hood, and we can get timely information in a scale of hours from people feedback of the events in our society. So the questions that we are seeking for a reply for them in this study is which topics generate the most discussions over social media, how and why the topic discussions transform to the other. So for example, a central tweet is discussing foreign policy, but then after some replies in a reply chain, it transformed to, for example, the next election or COVID-19. And then how different topics bond together to form discussion threads. Then using that, we can find the interrelation between different topics and how they get involved each others in a discussion. And more importantly, how deliberately the conversation are being formed on the social media, because maybe you notice that, for example, the central tweet is about COVID-19, but there are lots of replies about irrelevant matters. And we want to know in which topics a real conversation between opponent sides with to-the-point replies is being formed, and in which topics it's not coherent. And finally, we want to know which users are successful in generating cutting conversation between opponent sides. And it's a kind of another work to see if the social media is an echo chamber or a social media, because when you are a member in a social network, your friends most probably have the same beliefs and opinion toward social and political matters, and then you are exposed to the similar belief, and this is end up to a dichotomy between sections and different sectors of the community. So this is the main questions that we are looking for in this study. So the framework that we are using is so a new style of data collection that at the beginning we target a user or a topic, and then we start with the core using some keywords, and then using some fields in the packet of the tweets, for example, that we are collecting. We extend our data set using the users, the keywords, and whatever we have. And in the explanation of this slide, I explain how we are doing this. And next is reconstructing the network between users and tweets. We use these networks to visually summarize what's going on in one time snapshot on the social media. And finally, we use some novel NLP methods to extract the contents of those messages on social media. And I think you know that from 2008 to 2012, it was a kind of golden age for social network analysis, but after it was not much of research just like before, because it was fully exploited, whatever research question that we had. But the thing is, at that time, NLP was not mature enough. We didn't have word-to-vec models. We didn't have multi-head attention models. And now working on the intersection of NLP and social network analysis, we can respond lots of interesting questions, having both of them with each other. So we use, throughout the presentation, we use the term star and galaxy. It's a kind of metaphoric words that we are using to describe the discussion threads and reply chains or social media. And we use star for a central tweet and the reply chains around it. And we use it because it's kind of similar to how energy is gained by quasi-stars. So it gains the energy from the materials that falling into the core of the quasi-star. And similarly, what happened in social media is the energy of a central tweet increase over time as much as other users attach themselves by getting involved, replying, or liking, or retweeting the central tweet or one of the replies in the reply chains. And we use the term galaxy as a set of stars with a timely snapshot. So to get a sense from how a star looks like and how the network is look like, here we can see an example. So the central tweet is a tweet by Senator Bernie Sanders, who announced run for candidacy. At the center, we can see the central tweet, and then the first ring shows the replies, and then replies to the replies, and then all the replies in the reply chain. And the size of the nodes is proportional with the number of replies that each tweet gets. So the central node at the core is exceedingly large. And then the replies who raised more discussion and conversation are larger than the others. For example, the nodes that you can see here. So at the beginning, we try to quantify the size of discussion to see the spread of the central tweet, the message of the central tweet over social media. And it's not complicated. We consider the number of replies as discussability. We calculate the number of retweets for all the replies in a reply chain, including the central tweet, as penetration over social media. And we calculate the number of likes regardless of the content of the messages, because sometimes the replies may belong to different sites, but we consider all of them altogether, all the likes as the favorability. And then we have a kind of combined measure. To find the coefficients, the proper coefficients, we put lambda d equal to 1. And for the favorability and penetration, we use a very large data set, including 200 million tweets, to find the ratio between the number of replies and the number of likes, and also the number of replies and the number of retweets. And here are the coefficients that we got. So based on these results, the number of retweets is almost twice of the number of replies, and the number of likes is almost 10 times of the number of replies. And so here are the coefficients that we are using in this study. To get an idea that how the energy of the stars is distributed, we did a similar study that was before for example, number of followers, the structure of social network, and all the networks between users that was done before. And we got kind of similar result for the energy. So it's a power law distribution with exponential cutoff. And that means more than 99% of the whole discussion over social media is generated by less than 1% of the central tweets. We also did some studies, time series analysis, to see the pattern of the generated energy over time. So here we excluded the energy gained by the central tweet and just considered the replies. And it's interesting because we could find some similarities between the pattern of the energy over time, but I skipped that part to make it brief and discuss the most important result. Another measure that we look into is the centrality. And centrality means the portion of the energy by the central tweet compared to the whole energy by the replies in a reply chain. And low centrality means someone, a user on the social media, is successful in getting involved all the user on social media and generate large discussion and send the voice to a broad range of users on social media. And it was really interesting that for President Trump, it was 58%. That means 42% of the whole energy comes from the replies, and a diverse range of audiences are getting exposed to the content of the tweets. And for some other candidates and previous presidents, the result is almost similar. It's something between 0.8 and 0.9. And among Democrats, Bernie Sanders was the most successful in actually generating controversial topic to get involved lots of replies. So it was all about the size of the audiences, size of the energy, and the spread of the audiences of the central tweet. But what about the content? So to delve into it, we developed 3 different galaxies, which the first one is topic aware. That means we use a method to extract the topic of the tweets. The second one is deliberateness aware galaxy. And that actually designed to respond this question that regardless of the size of the discussion, really how many percent of the tweets or how much the tweets in a reply chain are generated thoughtfully, considering the contents discussed in the tweets that they are replying to. So we developed a new method, which is called deliberateness aware, to measure for different topics, for different users, how much the discussion has quality actually around that central tweet. And the last question is, if you remember, is which users are more successful in generating cross-cutting discussion? So we use a stance aware galaxies, and in the next slides, I explain how we get results using these three methods. So for topic-aware galaxy, we use an unsupervised model. And I know that maybe your field is completely different from NLP. I just try to give you an idea how it works and how we unsupervisedly, without any labeling, can divide tweets into different topics. If you are familiar with topic modeling, it's similar, but it's more advanced and is using deep learning based on the word2vec. Word2vec firstly was developed in 2013, and it tried to produce a semantic space of all the words in a dictionary in a way that the words with similar meaning are related to the same context, are located closer to each other. It's similar to what you can see here, that, for example, burger and sandwich are closer, and spaghetti and pizza are closer to each other. The same thing happened using the word2vec in the semantic space for the words. And how word2vec do this? It's go over a large corpus, for example, all the Wikipedia text, and based on the co-occurrence of the words in the same sentence, it's try to learn the kind of correlation between the context of different words and then generate that semantic space. And to give you an estimation, the semantic space typically has 300 dimension. So it's a large space. Also, we use attention mechanism. It's really interesting. It was developed in 2015 by Bahdano, working on language translation. And with attention mechanism, deep learning models try to focus on some segments of the words exactly in the same way that humans are reading the text to generate the kind of semantic representation for the whole text. So here is, for example, the tweet. So when, for example, a deep learning model with attention mechanism read a tweet, it gives different level of attention to the words in the tweet. So here is the model architecture. For example, we have this tweet: tariffs are bringing companies back from China to the USA, and then word2vec generates such vectors, and then attention mechanism assigns some coefficients. For example, here tariffs gets the highest coefficient and back gets the lowest coefficient. And finally, we specify number of topics. In this example, for example, it's 5 topics, and then using a dimension reduction that works, for example, like PCA that you may be familiar with, we reduce the dimension from 300 to 5, and then the coefficients show the topic with the highest probability. So as a case study, we collected 30 million tweets in 9 months, starting from January 2019, that are initiated by President Trump or someone else who discussing about him. And then using that model for topic extraction, we got these results. So the main topics are supporting president, criticizing president, public policy, next election, world news, some arguments, legislation, and referring media. You can see the keywords here. We don't have enough time to discuss the keywords, but we kind of verify that the result was reliable. And here we can see over time during the 9 months from January to September, which portion of the whole energy of the tweet contents regarding President Trump was dedicated to different topics. So some quick referring to intuitions. For example, criticize president increased in March significantly because at that time the Congress announced that they will publish some results for President Trump investigation for possible kind of information sharing with Russia. But at the end of the March, they announced that they don't have enough significant evidence for that. So during that month, the kind of critical tweets for President Trump was increasingly, but after it decreased. Or for example, for public policy, as in January, we had government shutdown. Lots of people are talking about this and argumenting that who is responsible for this situation, and over time it was decreased. Or for example, for next election, you can see the portion of the whole energy is increasing over time until the last September. And here is the galaxy. And we are working on finding some ways to visually summarize the content of the social media. And I think it brings more visibility for our result, and all the other research groups are working on social media. And here, for example, you can see all the tweets and the reply chains that initiated by President Trump or someone who mentioning him. And it was just for 2 days. So it includes almost 400,000 tweets. And as you can see, the referring media, for example, referring back to something that happened in a TV show, generate the largest discussion over social media, and it follows with some word news and then some criticals of the President Trump's. And the interesting point is, in that period of time, the critical tweets are being surrounded. I'm not sure that you can see because it's too tiny in some places, but the critical tweets are surrounded with blue notes, which are continuing the critics. But the supporting tweets for the President Trump are surrounded again by blue notes. That means at that time, the Democrats are surging and invading the central tweets that are supporting the president. And for example, here you can see a chain of discussion that is a continuance of discussion between two public figures, and then the replies around it. And so we can find lots of different applications using these galaxies. To have a sense, we can review some of the largest nodes in the previous galaxy. For example, the one who generated the largest discussion, this tweet is we are building the wall. So simple and clear. And we have some other tweets with Senator Schumer and some others, but I skipped this slide. Also, we can focus more to see what's going on in one specific star. So this tweet actually is about this tweet is about the tariffs with China. So President said, as usual, China said they were going to be buying big from our great American farmers. And then there are lots of criticals which are irrelevant to the message discussed in the central tweet. But as you can see, the tweets that maintaining the same topic and talking about public policy are generating some more discussion. And interestingly, there are even some tweets that even after 2 or 3 generations are generating some sub-discussions. For example, this one, he is subsidizing farmers with tariff money from China, not borrowed money. So we are searching for which forms of the tweets and using some AI to generate such tweets that are potentially generating more discussion rather than others. Here is another example for Senator Elizabeth Warren. And so as it's unsupervised, we don't have any control on fixing the topics. So the model automatically generates those topics. So here, as you can see, the abortion generate a very large discussion for the audiences of Senator Elizabeth Warren. But the ones who are talking about economy are not successful enough. And that means she was successful in mobilizing people for abortion rights, but it's not the case for economy and some other cases. Then we are working on deliberateness-aware galaxies. So here is one example to see how it looks like. Our children and grandchildren should grow up in a world where they can breathe the air and drink the water. And it's about global warming. And at the end, it says some more information, but the point is she's talking about children and grandchildren. And there are some replies. For example, the sad part is there for the portion of the country who believe her. So we are trying to develop a model that assign such coherency, for example, 0 in this case, and 1 in this case, who is talking about the global warming, that shows how much the reply is coherent with the content of the main message. To do that, we are using a new method to extract the content of the text, which is different from recurrent neural network and convolutional neural network, as a large line of research and tools in deep learning. And this is transformers. And transformers benefit from 2 different components, which is pre-training that is similar to what we had with Word2Vec. There is a large corpus and the model is trained to do some challenges, which is, in this case, is masking and next sentence prediction. With masking, we remove some words from the text and the model should predict those words. And with next sentence prediction, we randomly replace the next text segment that can be longer than the sentence, but in NLP, they use the term sentence for that. And then the model should predict if the next text segment is next sentence or not. And also it uses multi-head attention layer, and that means the model can understand different aspects of the text with different inclination at the same time. And the models are becoming similar to how human works after and after. So using that, the model can find some refers from the reply to the tweet and see how they are coherent with each other. This is the best visualization that we could get. We are working on it, but from this visualization for the tweets in 3 weeks that are initiated by Bernie Sanders and others, you can see the tweets that are maintaining the same content are generating more replies, while the other tweets that are talking irrelevant matters are not successful in generating more conversation between the people. So this star is talking about run for candidacy, and as you can see, there are lots of purple and blue nodes around. Maybe it's not completely visible, but for example here, which is for healthcare, the replies are more coherent and to the point. And finally, it's a stance-aware galaxy. I wrap up the presentation in 2 or 3 more minutes, sorry. So this is the most important part that we are working on that now. And with stance-aware galaxy, we are trying to see in controversial topic, what is the position of the people toward them. So in the case study that I'm explaining, we target hydroxychloroquine as a possible treatment for the coronavirus. And we are interested to see if the discussion over social media is a real conversation between opponents part, or people just affirming people with the same belief on the social media. So we first collected almost 400,000 tweets that are mentioning this word. And then we used some fields in the tweet packets to extend our data set to get all the replies to those central tweets who use the term hydroxychloroquine. And in converse to the 2 previous methods, which were completely unsupervised without the need for manually labeling, in this case, we needed some labeling. We manually labeled 2,000 tweets into 3 different categories. The first one are supporting the consumption of the drug at that time without the FDA approval. The second one was opposing the consumption, and the third category was neutral language or irrelevant. And based on our results, 29% have been supporting the use of that, 38% were opposing, and 33% were neutral. And we noticed that the criticism of using hydroxychloroquine increased over time. And more interestingly, neutral languages did not generate cross-cutting discussion. And they were mainly surrounded with significant majority of one side. So here is the galaxy that shows our result. And as you can see, some of the tweets that maybe they are news or some neutral languages are surrounded with people who are supporting the consumption of hydroxychloroquine. Here, there is a large conversation that initiated by a central tweet and then a reply maybe from a public figure or politician that generated another discussion. And yeah, so the important thing here is our results show there is no any response for is the social media is echo chamber or a social planet. There are some users who are successful in generating cross-cutting conversation, but it's mainly echo chamber, as you can see in this graph. And I forgot to tell, as the nature of such discussion is multilingual, we are using a multilingual deep learning model who can provide a same semantic space for the text from, for example, from English, Spanish, French, and some other languages. And it gives us the opportunity to target some multinational topics and see how's going on under the hood in a society in a timely manner. That was all. Thank you so much. And sorry for, it was, I think, some minutes more than the thing I expected. And I look forward to get your question and let me know if we can find an application in the field that you are working to validate some results. And we really like to collaborate with some other research groups in other universities.
Okay, are there any questions for Pouria?
I have a quick one. Talaya, did you want to go first? I heard you saying something there.
Oh, thank you. Yeah, you go first and I then ask.
No problem. So, well, thank you for the presentation to begin with. Pouria, very interesting. And we all know for a fact that Twitter has a lot of non-human activity by bots. Sometimes those bots may engage with the conversation in their own way, with those standardized messages that you see repeated throughout a thread. Sometimes it's completely unrelated. I mean, you may go to the newest tweet by Donald Trump, open a conversation, and there's going to be a bunch of memes about Obama being a criminal, stuff like that. So my question is, are those counted as people discussing? Like if it sounds human enough, the message posted by a bot, are you going to consider that as somebody engaging in the discussion?
That's a great question, actually. So the short response is we consider them as humans who responded, but we are working on using such a visual summarization to detect bots. And there are some new models developed with some other research group who get some tweets from an identity from a user on social media and then give a measure from 0 to 1 as a probability that it's generated by a bot or by a user. So it's something that we are working on, and that would be really interesting because they don't have any limitation on the size of the content that they can add to the reply chains. And that would be great if we can limit their effect to navigate the discussion towards something. Maybe they want to increase the dichotomy between people, so they are sending extreme tweets with extreme opposition to a different size. Yeah, so we didn't consider that yet, but we are working on this, and that would be great if you have an idea and we can share. after the presentation with each other.
Thank you. Thank you.
Thank you so much.
Uh-huh.
I have a question regarding your presentation. It was a very interesting topic that you're working. I couldn't understand the novelty of the method that you propose. What is the difference of this method with autoencoders?
You mean, oh, sorry. The architecture that the architecture that we use here for a stance detection, or
no. Actually, it's two or three slides earlier than this.
Okay.
Of this one, yes.
Yeah. Oh, yeah. So here is the structure of transformers. For example, the landmark of them is BERT or XLM for multilingual. I just put the structure of the typical structure of the transformers here. So it was not part of our works. Our collaboration in developing models was here, that actually we tried in some competition, including in SEM-eval, and this architecture was one of the successful models in stance detection. But for this one, which was explaining how the transformers are work, it was, as you said, it was the structure of putting some encoders back to back to get the syntactic and semantic information from the text, and then using a dense layer on the top for possible classifications.
Right. So you use encoders as a dimensionality reduction to reduce the dimension of the data, right?
So actually, the development of such architecture, which is completely different from recurrent neural network and CNNs, was kind of accidental. In 2017, now it's very famous with more than 4,000 citation, which is attention is all you need. And instead of those complicated structures like LSTM and others, they just put some encoders. But so at each layer, we have, for example, 12 different linear layers. And then the result of those linear layers are combined in the next layer. And now they are working on this, that's why it works. But the interesting results show in the low layers, this deep learning structure can learn something about the syntactic. For example, the relation between a verb and an object, or relation between a co-reference resolution and a word that it is referencing to. And after it can understand some more complicated information, the semantics of the text, some complex context in the text. So they developed this, it's completely simple, just some linear layers, but it can grasp something from the raw text, which was impossible maybe 3 or 4 years before. If you are interested, you can see that paper, Attention is All You Need, and the paper that is introduced, BERT, that was developed by Google in 2018. And let me know if you have any idea to apply this model in your field, because it was developed in text mining, but it can find its application in all different domains of optimization with different inclinations with complex space. I didn't see something in the other fields, but it was my understanding of how it works.
Thank you.
Thank you so much.
I do have a question for you if there is time.
Hi, Ivan. Go ahead, please. Thank you.
If you could explain the difference between the word-to-vec and when we do the topic modeling, there is we usually create a matrix. They call it word and document matrix or something along these lines. So what's the difference between these word-to-vec and the topic modeling approach?
I see. So at the beginning, we have been using topic modeling, and as you know, from 2003, that LDA, the landmark of topic modeling, was developed. There were lots of different versions of topic modeling, and even now we can see journal papers who are still using topic modeling. And it was actually before they were developing successful deep learning models. And it works. It works perfectly in some cases, and it's really straightforward. But the problem is topic modeling assume a kind of distribution of the words in different documents, and using those distribution try to bind some documents together and then extract topics using the words in those document binds. But here's the point. For example, when you have some synonym words that are coming in those documents, LDA fails to aggregate the knowledge from some similar words, some words that are representing the same thing, and actually it cannot generate one layer on the top, which is a semantic space that deep learning is successful in. And there are some results. For example, the work by Roy and he, I can share it with you, that share topic modeling with this structure for some benchmarks in NLP, and in all of them, these kind of a structure, which are based on word-to-vec, are more successful. And the reason is word-to-vec can generate a semantic space that aggregates some words. So let's say, for example, you have some words for the colors, pink, white, red, and some others. Topic modeling cannot understand that they are representing colors. And then when it see white, it can aggregate the knowledge from the white, seeing the word white, and the knowledge it can get from the word red. But word-to-vec, with this semantic space, puts these words that are representing color close together, and it gives the model the opportunity to aggregate such small knowledge rather than depending on just the kind of a statistical distribution of the words in the documents. If my explanation was not clear, I can share that paper with you, the paper I mentioned with Roy Dunhee. And there it was a long discussion about the benefits of word-to-vec based model in comparison with topic modeling.
So yeah, that's very good explanation. I have a follow-up question. So the ultimate goal of the topic modeling or the word-to-vec is to do like clustering of different maybe documents or tweets or whatever thing that we, is this correct?
So in this specific study, the ultimate goal is classification, but in all the actually they are now from 2018 or 19, they were superseded with BERT and multi-attention model. But before that, from 2013, 2018, word-to-vec was a typical layer in all deep learning structure, because we want to have a space, a vectorized space to do some post processing for some more kind of analysis. It can be used for language translation, for sec-to-sec model, any other thing. Here is classification, but it has its application in wide range of domains. And the interesting point is you can add some words and get meaningful results. For example, if you add man, king minus man is equal to queen minus women. So word-to-vec is being used to generate a meaningful space of the word. And yeah, it can be used for classification, but of course it has some other applications.
Yeah, that's good. I'm interested more in the technical side of it. So if we, so if you give more detail about about the process that you go through, like I have document, for example,
I see.
is it the case that each word, if I feed it to the word to Vic, is it that the case that each word will be translated into a vector, or
Exactly.
what happened to the whole document? Like if I have a bunch of document that I would like to maybe classify, what's the process that I need to do?
So assuming that Word2Vec is working completely, or how it extracts the vectors, to make sure that I got your point.
So I take this scenario. So I have maybe set of documents that I know there is a kind of topics within them. That my ultimate goal is to classify these documents into
Got it.
groups. Okay, how will I go toward applying the word to Vic to do the classification?
I see.
Like
So
what steps I need to go through?
I see. So to provide a brief explanation for this, Word2Vec use just one layer. It's a shallow deep learning, just one layer in the middle with, let's say, for example, 300 dimension. And then Word2Vec is trained by giving the input and as a sentence, for example, and having the same sentence at the output. And then at each specific time, we focus on one word and then try to predict the context word. So it was the first step, that the model tried to understand the relation between the words, the closeness of their contents and other stuff. So after getting those vectors in the first layer, then it has some vectors. So for example, here we have 6 different vectors. And based on the closeness of those vectors to each other, based on how they are located in that semantic space, it gives the coefficient to the words that are close to the other words. For example, tariff, companies, China, US are the words that are representing something, and they are kind of correlated with each other. It's not the case, for example, for the word back. And then it's a kind of average. It's a weighted average between those vectors for the words. And then we try to kind of auto encode that vector that we has from, for example, 300 to 5 dimension, and then reproduce the vector in the output. So based on how much the vector in the output is similar to the vector that we had before the dimension reduction, we calculate the loss. And using that optimization loss, we optimize the coefficients, the linear layer that is used for dimension reduction. And after in a kind of training, we don't use labeling, but it's a kind of training. It's a auto encoding model. We have a sentence in output, and we want to see after this dimension reduction and reproducing this, how much the output is similar to the sentence that we had in the beginning. So it's a whole process of the kind of training the model to extract the topics from the text.
Okay, Pouria, thanks so much. Perhaps Amin can email you and you all can get together.
Of course, I really appreciate if you.
I have another question.
Okay, sure, go ahead.
Yeah, I have 2 questions actually. The first one is about the data that you collected for 9 months. So did you collect this data as real-time data, or you use some API? And if you use API, what was that API like that allows us to collect this long data for free? And my second question is about the tweets that doesn't have label. How you dealt with those tweets? Because I saw that you use tweet based on their labels.
For the stance detection?
For the first one, yeah. For the first case study.
Okay, so first of all, for collecting the tweets, actually we use Twint mainly beside some other packages like 2RC, and they are using Twitter API. But as you know, there is a limitation of 1 week for the historical data.
Yes,
so
that's correct.
Yeah, that's right. We don't have access to the data from 1 week before. So Twint is a package that we are using. It doesn't work completely now, but it's a kind of, so we are running the 2RC, which is working with Twitter API from a year ago on a system on our server. So we have some tweets. Using that core, we extend our information using Twint. And Twint is a package which is developed, which is not based on Twitter API, and it gives you access to the historical data, even from 10 years ago, but it's too slow. I mean, for example, with Twitter API, you can get millions of tweets in 1 hour, but it's in a scale of thousands. But we need it to kind of generate the reply chain. So it's a kind of combination of Twitter API with Twint to fix those gaps on the Twitter. So it was about the first one. About the second one,
Oh, okay, go ahead.
Go ahead, please.
No, I thought you wanted me to repeat the question.
Oh, no. I got your question. So the point is the topic modeling is unsupervised, and so how it works is it's auto-encoding. So we have a encoder at the beginning and then decoder, and in the middle we have a kind of vectorized representation, and we try to find the best vectorization for the sentences, for the tweets actually, the best vectorized representation for the tweets. And using some loss function, which I explained in the previous question, we try to find the best vectorization for the tweets in a way that in the output, the vectorization is similar to what we feed as the input. So in the input of the encoder, we have 300 dimension. In the output of the encoder, we have 5 dimension, for example. And in the output of decoder, we have 300 dimension. So we tune the coefficients of the linear layer in the deep learning model to find the most optimized location. And then at the end, we extract some numbers, some 300 dimension numbers for the vectorization of the tweets. And then using those vectorization, we can use k-means or some other clustering algorithms to define topics. Because for some tweets kind of generating clusters of the representation that are located closer to each other. But of course, I can share the papers to explain in a better way how it works.
Thank you so much. That would be perfect.
Of course. Thank
Hi,
you.
Pouria. I have a related question. Last one, sorry.
Okay.
You know, so when you obtain the data, did you use the web scraping? So if yes, did you use Python or other tools? So I mean, how did you obtain the data from the website?
Actually, we use the scrapping for example, Amazon Review and some other websites. But for Twitter, there are some packages that make the life easier for us. So we didn't go through a scrapping. The thing that, for example, the packages like 2RC or Twint is doing is scrapping, but we didn't go into developing a new package that scraps data from Twitter. And it's on Python. Everything we did from the the visualization was using D3. It's a kind of interactive representation of the networks that can be used, for example, on the website, but everything else was on Python. And I can share the packages that we use if you are interested to use those.
Okay, thank you so much. Thank
Sure.
you.
Of course, thank you for your question.
Okay, thanks so much, everyone. Some awesome questions and some conversation, and presumably you can search for Pouria on the web and find his email address for conversations later on. Thanks so much for everyone showing up. And next week, looks like we have Benjamin from Purdue making a presentation next Wednesday. So thanks for coming in, and I'll see you all next week.
Thank you, everyone.
Thank you.
I really appreciate it.
Thank you.
Thanks.